Hello and a warm welcome to everyone. It is my honor to present at this year's SEEDS conference. This research was conducted in partial fulfillment of the degree Bachelor of Science Honours in Construction Management, completed through the Department of Construction Management at Nelson Mandela University. My name is Ashvin Mang. I was the principal investigator under the supervision of Christopher Allen. This research effort investigated the change in indoor air quality and occupant well-being before a mechanically ventilated office building was retrofitted to allow for natural ventilation. The building's sealed windows were retrofitted into openable windows. The change in indoor air quality and occupant well-being resulting from the window retrofit was captured and analyzed. Before presenting the research, I will first introduce the topic of indoor air quality and why, as built environment professionals, indoor air quality needs to be considered during the design process. It seems fair that in 2020, with 5,000 plus years of building experience as a species, we deliver buildings that do not make us sick and at the very least promote occupant health. So why is indoor air quality important? I love first principles thinking, so let's begin with an axiom we know most to be true. Human beings on average take as many as 24,000 breaths each day. Considering the average volume of a human breath is 0.5 liters, we are breathing in 12,000 liters of air each day. It's always good to accompany a metric with a visualization, so 12,000 liters of air would be not one, but two of these party-sized pools. Next, there is substantial empirical evidence indicating that we are spending about 90% of our time indoors. Considering how we live, work, and exercise primarily indoors, 90% makes sense. Even if we just consider that in a 24-hour day, 1/3 is sleep in a bedroom, so make sure the indoor air quality in your bedroom is healthy. Lastly, according to the EPA, the levels of indoor air pollutants are often 2 to 5 times higher than outdoor levels, and this is largely because of insufficient ventilation. Indoor air quality is definitely important, especially considering how we are called the indoor generation. But is it a problem? It turns out indoor air quality is a rather big problem, killing 1.6 million people in 2017 according to the Global Burden of Disease. I have found the problem has two causes. First, air quality is not considered with life-threatening importance during the design of the building. And second, it is difficult for an occupant to notice indoor air quality as a problem. Example, when an occupant experiences reduced quality of sleep, their first thought isn't high carbon dioxide levels in the bedroom. Today we have affordable technology that allows us to measure and then manage indoor air quality. This is the Air Visual Node by IQ Air, a medical grade air quality monitor, and the monitor that was used in this research. This research was conducted in the city of Port Elizabeth, South Africa. The building investigated represents a typical modern office building in Port Elizabeth and was constructed in 2009. The building was designed as a mechanically only ventilated building. The building is located on a main road and has been occupied by the same tenant since its construction. This is a Google Street View of the building. The 4-pane window that can be seen is a sealed window. The retrofit consisted of removing one of the glass panes and retrofitting an openable window to the existing aluminium frame. The office space has 14 windows, in which 7 were retrofitted into openable windows. The aim of this research was to determine the impact a natural ventilation retrofit by openable windows will have on indoor air quality and office user satisfaction of a mechanically ventilated office building, by investigating the impact openable windows will have on indoor particulate concentrations, investigating the impact openable windows will have on office carbon dioxide levels, investigating the impact openable windows will have on set building syndrome symptoms experienced by employees. 2 quantitative research designs were used to achieve the objectives: an experimental design that captured data with an indoor air quality device, and a survey design that used a questionnaire to capture data on the 22 office users. The research period took place over 13 weeks. The mechanical ventilation period was 8 weeks. The pre-SBS survey was circulated on the 18th of June 2019. The start of the experiment. The hybrid ventilation period was 5 weeks, in which, at the end, the post-SBS survey was circulated. The device was placed in 3 central locations within the office at a height of 1.6 meters. The 3 locations had the same characteristics, and the indoor air quality data did not reflect any significant change from moving the device around. The indoor air quality data was captured in real time and analyzed in Excel. An overview of the air quality data was created, and IAQ violations were flagged in red. Here you can see a zoomed in capture of the overview and the violations marked in red. An analysis of the 14-week real-time data revealed that the pre-openable window period had 12 incidents in which office carbon dioxide levels exceeded 1,000 parts per million. The office carbon dioxide level exceeded 1,000 parts per million for a total of 36 office hours. On average, office CO2 levels would exceed 1,000 parts per million 2 to 3 times a week. Once the openable windows were in use, the office carbon dioxide level did not once exceed 1,000 parts per million for the remainder of the experiment. It was as if occupants would instinctively open the windows when carbon dioxide levels were greater than 800 parts per million. Similar to the CO2 exceeding 1,000 parts per million, the office AQI incidents greater than 50 reduced from 16 incidents during the pre-openable window period to just 1 after the window retrofit. The results from the pre and post SBS symptoms survey correlate with the indoor air quality data, as the top 2 SBS symptoms were tiredness and poor concentration, both of which are common side effects of high carbon dioxide levels. The post-SBS results show there was an improvement across almost all SBS symptoms. In climates such as Port Elizabeth, South Africa, hybrid ventilation systems provide a true solution to sustainable ventilation within buildings. The sealed office design with mechanical ventilation is inappropriate by design for warm and temperate climates. Warm and temperate climates can exploit passive design principles for a large portion of the year, relying on mechanical ventilation occasionally. Natural ventilation retrofits can be extremely successful in improving indoor air quality and occupant well-being. The reduction in SBS symptoms experienced by occupants potentially provides a massive return on investment by improving worker health. The cost of this retrofit was 25,000 Rand or £1,120. Measurement is an important first step. Until you measure, you simply do not know what you are breathing. I will conclude this presentation with 2 quotes, one by Peter Drucker, "What gets measured gets managed," and one by Steve Jobs, "Design is not just what it looks and feels like, design is how it works." Thank you so much.